Everyone. I thought what I'd do today is we've pretty much covered everything that we need, from this section, from this chapter, in fact, and for the midterm. But I thought we'd do a few more, example of each, just to keep our hands in. So I've decided to go for this one, which is number 15, or at least it's my version 15. And you've just been asked to find the tangential and normal component of acceleration. And here's our two favourite functions. So I think I'll start over here. If my memory serves me right, I probably did a helix the first time, because I kind of do helix the first time with everything. So find its derivative. That's not going to be a problem. You find its second derivative. Okay, that's interesting. That is very interesting. This acceleration vector, because that's all the second derivative is, you see it's acceleration vector. A lot of zeros in it. So, I'm now going to find the dot product of essentially the vector and acceleration. Do you know I could have had this written down with that notation? Wouldn't it mean exactly the same thing? So we move on, and what's it basically? It's going to be 1 times 0, 2t times 2, and 3 times 0. I think I may have chosen too easy a question. I didn't realise it was going to be that easy when I picked it from the homework list. Oh, that's fine. 4t. I need to know the magnitude of this vector. 1 squared, 2t squared, 3 squared, 10 plus 4t squared. Okay, nothing. You can't do that. I guess I could pull out a 2 as a common factor. Would you agree it's not worth doing? I mean, if there was 25 and 50 or something, I might have pulled out 25 to make it a little bit prettier. If it was a perfect square, I would be expected to do that, right? But you can tell that can't be a perfect square. It needs 3 terms, right? We're used to what perfect squares look like. We might even be used to the shape of them. They kind of have a shape to them that makes you think, even if they're weird looking, they kind of have a guy, and then a guy that looks like him but the opposite, like an e to the 3t and then the other guy's an e to the negative 3t, or a t to the 4 and the other guy's a t to the negative 4. Don't allow them to have that kind of asymmetric symmetry to them. They kind of look like that, but not this one, so it's finished. So I need to get the tangential component, and it's basically made up of the dot product divided by the magnitude of this guy. And the dot product ended up being 4t, and the magnitude of this guy ends up being that fella. And that's about the end of the line for that one. I don't think anything else. Now, to me, this is superficial, but I don't know if WebAssign thinks it is. Typically, you shouldn't leave square roots in the bottom of anything, right? You shouldn't leave something as 5 over root 2, right? Certainly for numbers, I would accept that that makes sense. I'm not so sure it makes sense to rationalize the denominator, but just in case, you plug that in and it says no. Then if you rationalize the denominator, you get that. If you do a quick divide top and bottom by 2, You get that. So maybe the WebAssign's happy with this. Maybe it needed that. That's not a big problem in the midterm. If you stop there and you plugged it into WebAssign midterm, and WebAssign comes back and tells me that you're wrong and you're getting 0 out of 20, when I look at your work, and I'm just going to say, yeah, that's the right answer, and I give you your points back. So you don't need to be so concerned about the idiosyncrasies of what WebAssign thought the answer should look like. So there's another good reason, right? I'm selling the fact that you need to show me working. I need to see it for lots of reasons, and there's a good reason to show me. Oh, here's just a little. Isn't the tangential component of acceleration the dot product of velocity with acceleration and divided by the speed? I don't know if that helps me. It doesn't help me, but maybe it'll help people who are into the dealing with motions of objects. Maybe that's something that to them makes sense. Can the value of AT be negative? Could I get a negative number out of that? If I plug t equals 5 or something, or minus 20, could I get a negative number out of AT? Yes.
Yeah.
Yeah, possible. Can I get a negative number out of AN?
No.
Now, I have no idea why that's true, but evidently when you are looking at, and by the way, these two guys, and the reason they get their name, I'm sure I've told you, is that if you find the acceleration vector, it's made up of a linear combination of the tangent and normal vectors. Now, why this is allowed to be a negative multiple of that, but you must use a positive multiple of that, is a little bit, I don't know the structure of why that happens, but it's kind of curious that it does. And visually, if you take a space curve and you do your thing, at this point here, the vector going in the direction of your death is your velocity vector. At right angles to that, going this way, you're going to be looking at your acceleration vector. And basically, doesn't the tangent go in this direction and the normal go in that direction? They're just different, multiples of each other, which is kind of interesting as well. So, I mean, if you delve into the mechanics of that, I'm sure you'll come up with quite cool results. Okay, so I need to find the second fella. So I already know what these two are because I've got them here. So I'm going to find the cross product of the first and second derivatives. And that's going to be an I, a j, and a k. And the first derivative was just that. And the second derivative is that. And that's going to get me so many i's, so many j's, plus so many k's. Get my little pen out. Here we go. Nothing take away 6. Nothing. Oh, take away nothing. 2 take away nothing. So we get -6, 0, and 2. Let me check that. Yeah? Yeah. Yeah. This cross product does not contain any t's. In fact, this cross product is a fixed vector, right? It's the same vector all the time. So when I find the magnitude of it, it won't have any t's in it either. It's going to be the square root of 36 add 0 add 4, which means it's going to be the square root of 40. We already know what this guy is. I'm just writing him down again. He's this fella. So when we get the normal component, we're looking at the magnitude of this vector, square root of 40, all over the square root of 10 plus 4t squared. And you could do some tidying up on that if you felt you needed to for homework purposes. I think that matches really well with our conversation at the start. It's pretty obvious what you need to do, isn't it? Just the mechanics of being careful. Now, I didn't, as I said earlier, I didn't realize this one was going to come out quite as nice as it did. Do you want me to do an uglier one, or can we just say, you know, it's the same process, just but with uglier bits? Anybody got a preference on that? Do you feel you know how to do these, no matter what the original happens to be? Okay. So there are some little tidy up parts to this. Have you noticed that these questions have been done in the general sense? In other words, t could be any value. Right. You could get the same question, but they only change it in this way. Find those vectors, the tangential and normal component, at a specific point in the curve, right? Say at t equals 1. Now, it wouldn't really change the mechanics. Would you agree you'd pretty much do that? And wouldn't the only difference be at the end? In this question here, wouldn't you just replace the t by 1 and replace the t by 1 here? And what would that get you? 4 over root 14, and then you could make it look pretty. And over here, wouldn't the answer be square root of 40 over 10 plus 4 over the square root of 14, and you'd make that look pretty. So these are the general versions. In other words, for any given value of t, this is the normal component of acceleration, and this one here will be the tangential component of acceleration. So I'm going to put that down as like your standard template on how to do that particular kind of question, right? Because they're all going to look pretty much in the same family. Okay, let's try this fella. Acceleration, t to the t, 4 over the square root of t, and 3t squared plus 1. So we're being told the acceleration vector, and I'm going to tell you that the velocity at 0 is a vector 1, 2, negative 1, and that the position at 0 is 1, 3, 0. So this is another example of the working backwards method, right, where you integrate things to get what you need. Are we comfortable that you recognize this kind of question and what the process is going to be? Because it's all about process. So let's see how I'm going to use that. Well, to get the velocity vector, don't I just integrate the acceleration vector? And in this case, that becomes the integral of te to the t dt, the integral of 4t to the power of negative a half dt, and the integral of 3t squared plus 1 dt. And we're a fair distance to there. Okay, probably do this as some working at the side. Do you recognise that to integrate this, you're going to have to use the integration by parts method? Side question. What method will you use to integrate this fella? He's very similar looking, but not the same.
U-sub.
U-sub. Do you see what a small difference can do to the technique of integration? I think sometimes we get caught up on U-subs will save your day. You know, if you don't know what it is, it's a U-sub. It isn't always a U-sub. It can be integration by parts, right? So if you're looking at something that is a U-sub, that's an integration by parts. I'm going to do the f of t, big G of t, take away f dashed of t, g of t. And somebody said a really cool thing with voodoo in it, and I've forgotten the rest of it. What was that phrase to remember it? Something, something voodoo.
You do voodoo.
You do. That is a good one. Right? You do voodoo, right? So for the UDV people, in this case, it's going to be t e to the t, take away the integral of 1 times e to the t. So that gets me t e to the t, take away e to the t, plus some unknown arbitrary constant that we'll call C1. I think it was Abigail. Question?
I think there's someone waiting inside your.
Oh, thank you. Hope it hasn't been waiting too long. I think it was Abigail that was saying that when you look at the textbook, they had a plus C, but the plus C was actually a vector C, so that's the C1, C2, and C3. Interesting that they did it that way. Right, if you wanted to do this fella, first thing you have to recognise is, don't you sometimes have to change things algebraically to make them easier to integrate? There's not a lot of, it's not a good idea to leave that as 4 square root of t. You're probably not going to get very far. In fact, it's not a good idea to leave it as 4 over t to the half, because that doesn't really help either. This fella here is algebraically him. But this fella can be integrated because it's being a power rule. So I would add 1 to the power, and then I'd divide by the new power. And then I'd add an arbitrary constant. And then I would use the style point rule. Style point is just my name for that. You should make the answer as simple as possible, right? Like factor it and do nice things like that, typically. And you should also try and make the answer have the same format as the original. So if the original had square roots in it, your answer should have originals. This is the equivalent to that, but it's not considered good form. So I have an 8 square root of t plus c2, and then this one here is too easy, so I'm just going to call it t cubed plus t add c3. Right, so at this point, we have the general version of the velocity. What we're going to do is we're going to use this fella up here to essentially find out who C1, C2, and C3 are. Now, if I evaluate the velocity function at 0, I get 0 times 1, take away 1, add C1. If I evaluate it here, I get 8 nothings plus C2. And if I evaluate it here, I get nothing plus another nothing and a C3. And we are told at the top here that it's equal to 1, 2, -1. And all I'm doing now is matching up each of these, and I'll be able to get C1 and C2 and C3. These two here are easy. C3 is -1, and that one's easy. C2 is 2. And this one here is not that bad. You add 1 to both sides, Are you happy about C1 being 2? So put that package together, and we now have the velocity function. And it's going to be TE to the T, take away an E to the T plus C1. The middle term is going to be 8 square root of T plus C2. And the Y component is going to be T cubed plus T. Yikes. I shouldn't have written the plus because it's -1, but it's easy fix, right? Big thick 1, and we're good. Right. It has a very predefined process. I mean, you integrate 3 things. You use a boundary condition to find out what the arbitrary constant values are. You put the package together, and now you've got the complete velocity function. And don't I basically just do the whole thing all over again? I take my velocity function.
Did I end up missing something on your velocity where you have the +2 for C1? Shouldn't that be 1?
This one here? Yeah, well, let's see what's happening. -1 plus C1 is equal to 1. So C1 has to be equal to 2. I'm matching the x's together. So it should have been 2. Yeah. See these 3 numbers here? They aren't always the value, the end value of C1, C2, and C3. They are the values that you use to find out what their end values are, but they aren't always the same. The last 2 just happen to be by coincidence or whatever, but the first one had to be 2. Make sense?
Yeah, I'm blindly following along right now, and it just didn't make sense.
Does it make sense now?
Yes.
Okay. I'm going to suggest I just go ... here because I think that would be a waste of your valuable time. Would you agree that I could just take this function, integrate the 3 things, and then do essentially the same process using these numbers now to get the arbitrary constant? And that would be the finish to the question. Do you want me to finish this question, or is it okay to say, look, just do it again and you're ready? I don't have any opinions one way or the other. Oh, we're good. Okay, I'll move on. So let me go in to wherever I put the homework. Oh, 2 more people to come in. Here we go. I'm just doing a quick scan through to make sure that we have essentially covered everything that we need. Yeah. Here's a space curve, velocity, acceleration, and speed. Here's a helix, do the same thing too. Here's just a messy thing. I get a feeling I promised to do one. Did I say I was going to do something like 6 or 5 or something? I'm just looking at some of these.
Yesterday.
Yeah. Well, let me throw it on this way. You should be looking at 5, 6, and 7 here. And these are the, here's the space curve, find velocity, acceleration, and speed, right? That's those questions. Is there anything in those that you would like me to, any one of those 3 that you'd like me to do?
Maybe 7?
7? Okay. So I'll write this fella down. And I'll kick out and kick in. Weird question. Normally you get the space curve like this, but do you see they've pulled out a common factor of e to the t? Right. So I'm saying normally you just get a space curve where everything's together, but here they've pulled out e to the t. There are two different ways to approach this question. The first one is just stick them back in. So differentiate, 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 and off you go. You know that'll work fine. There is another way, just to show you. Now it looks slightly weird, and you have to be really careful. F of t is a scalar function, right? It's a one-dimensional function. It doesn't have three x, y, z components to it. It's just a normal thing. That guy there, this fella here, is e to the t, right? This fella here, on the other hand, he is a vector. We are going to be differentiating here, right? To get the velocity, I'll differentiate it once. To get the acceleration, I'll differentiate it a second time. If you write the function in this way, there is a formula for finding its derivative. And it is, not surprisingly, a version, and I'll put the word version at the front, it's a version of the product rule. It will be f dash t j of t plus f of t g dashed of t. So I'm going to go through this question and show you this, because it might be a nice technique for you to try to reduce workload. Now, if you find it awkward or you don't like this technique, haven't you still got differentiate him, differentiate him, differentiate him? So let's see what it looks like. This is e to the t. This guy here, the one I'm calling g of t, is just cosine t, sine t, and 9t. Now, let's see how it works. If you differentiate this guy, you just get e to the t. If you leave this fella alone, you get cosine t, sine t, 9t. Plus, if you leave this guy alone, you still get e to the t. And then you differentiate this guy, you get negative sine t, cosine t, and 9. Now, do you see these share a common denominator, common factor? And you now have cosine t, take away sine t, add cosine t, and 9t add 9. Are you cool with me pulling out the e to the t and then combining the terms together? It's essentially a factoring process. Did you also notice how quick that was? Now, if I write it this way, it will work, but won't I have to do an individual product rule to get this answer? Then won't I have to do a different independent product rule to get this answer? And that guy, yet again, an independent product rule. So don't you have to do 3 product rules and combine the terms and do all the usual stuff? Or you could do this. Can you imagine that this version, I have to stick the word version in front of it, this version of the product rule could reduce your workload. So if you like it, you know, do it. If you think, nah, my brain's got too many things in my head, I'll just do it a little bit more mechanically. That works too. Now, if I was wanting to do the second derivative, Wouldn't I call this guy my f of t? And wouldn't this be my vector g of t? And then I'd do the thing a second time. And I think if you did it this method the second time, it would save you a lot more work. Because if you keep it in this, mechanical version and just rote version, can you imagine that this guy is pretty big, but won't its derivative be even bigger and uglier because you'll have two things that you need to, there'll be all sorts of bits and pieces floating out that you have to differentiate. So I'm kind of selling this thing that you can do this. When should you do it is a better question. It's not a thing you can do a lot, but if you ever have a function that has this feature, that all three terms have a common factor that you can pull out. Can you imagine this has a common factor of sine? This one here is like that, and a common factor of t. Can you imagine some ugly thing, but all the terms have a log t with them? Can you imagine in those cases you could pull out a single common factor, then this version of the product rule could save you some valuable time. And probably you're less likely to make mistakes because there's less footy bits to keep an eye on. We cool with that? Have you seen that before? Did you notice it anywhere? No? Well, now you do. Well, while we're at that, we do not have these questions, and there are none of these questions that I can see anywhere, but let's just pretend that I had a function, I'll call it f of t, and it was made up, I can't call it f of t, got to pick some letters here that I haven't used. H of t, good, h of t. And it is a scalar function. Won't a dot product always give you a single dimensional function, right? A scalar function. So imagine that you had this function dot product with this one, and you are still going to be asked to find its derivative. There is a different version of the product rule, and it is called f dash t dot g of t plus f of t dot g dash of t. Isn't it elegant that the dot product behaves very like a product? The good old-fashioned two things multiplied together product. And for the last one, suppose you had the cross product of two functions. Got it, right? Now, isn't a cross product a vector? So this would generate a vector. So I should call that vector function h of t. What do you think its derivative might be?
Probably f prime of t cross g of t plus f of t cross g prime of t.
Now, if you had been the first mathematician to create such a question, do you know intuitively that would be your guess, and it is correct? All you would then need to do is do some clever math to prove it, and then you wouldn't publish it in a big paper, but you might mention it in one of your fancy lectures, and everybody would go, ooh. Right? Isn't it nice when it does what you want it to do, because not all the time do you get what intuitively you think the answer should be, right? But it is kind of nice when it does do sensible things. What that tells us is that vector functions are not unlike just normal functions. They just have like 3 dimensions to them instead of 1. And a lot of the things that we deal with are exactly the same kind of processes. Right, so we've got tons of time. I want to spend the last part of today talking about your midterm and showing you some stuff. But before we get to that, is there any general comments, anything from the past that you would like maybe to go over first? Something from week 1 or week 2 or Monday or whatever? I am going to put that as a positive thing then. It means that as far as you know, you're on top of it, right? You know what the heck's going on. You're quite comfortable with it. That's cool. I can handle that too. I guess then it's time for us to start talking about your midterm. Should have it set up here somewhere. What the heck's that? Nope. Go away. Yeah. You are all looking at the wrong class, but at least you're looking at Canvas. Are you all looking now at, what the heck am I doing today? There we are. That's our Canvas page, isn't it? At least that's what I hope you're saying. Okay, that's good. So what's going on here? Well, let's kind of start at the end. You've done your test, your midterm, it's finished. It's going to start at 7. It's going to finish at 10. I had to do a quick check in my brain there. 7 till 10. And you still have to get the working to me. If you want to get your best grade, you best do that. So if you click on this, it gives you a link to a thing called Adobe Scan. And if I click on this, I don't know, are you now looking at the Adobe Scan site? Right, so if you've got an Android phone, you click on Google Play and you download it. If you've got one of those Apple things, you hit that guy, you download and add it. And it's, oh, here we go. Basically, you take pictures of your notes, and this piece of software will take your, I don't know, let's say you've got 8 pages of notes. It takes your 8 pages, turns them into a single PDF. What you then do is you then upload that PDF into Canvas, and that's where I will find it. So hopefully when I come back out, right, we should be back up to our normal site. So imagine that you've taken picture. It might be a good idea just to do a dummy run. And all I mean by that is, you know, get a piece of paper and say hello, and another piece of paper saying today, and use it to do 2 pages to see that you know the process of how you turn it into a PDF and all the tweaks. Because there are always tweaks in a piece of software. You might not know, you know, which button to press to put the 2 files together, you know, the 2 pages together, whatever. You might discover that you need more light. And if that's the case, when the test is finished, go to go to your kitchen and take a picture of it in there, right? So you've got it as a PDF. Where do you go now? Well, you upload it to Canvas, and that's how I get to see it. I'm going to try this fella here. Do you see there's a guy here, Math 163 midterm, upload your working here when exam finished, deadline 11 AM. I don't think I could get more information in that one title. Right? So I'm going to go on to student view because that's what I need. Well, let me see if, just in case, are you looking at a thing that says you're currently logged into student view? Okay, good. So you've done it, you've got a PDF. I would, me personally, because this is how I do it when I send PDFs to people using my phone, I send that PDF to my email address as an attachment. I can then go to my PC and look at my email and download it onto my desktop, because to me it's easier on a big screen than it is to on a tiny little screen, right? Canvas isn't particularly friendly on small screens. So anyway, you click this guy. Now, hopefully you are looking at a thing that says submit assignment. You see that guy up there in red? This is a video that basically takes you through the steps, and pay no attention to the date. It was made for a particular time, but the steps are the same. So you've got on your computer, your laptop, whatever it is, maybe your cell phone, I suppose, your PDF of your working. It's pretty easy to do. Submit assignment. And you see this appears. Choose file. I don't know, if you use Dropbox or OneDrive, if that's where you put it, that would work. But I'm just doing it as a file upload. Choose file. Now, what you're looking at here happens to be one of my folders, but that's fine. You find where you put it. And can we pretend that that was your file? So you just click on your PDF. You hit open. And if you look really carefully, do you see the partial name of it is here? Just give it a few seconds to make sure it's uploaded. And then submit assignment. You see, it's not that hard. Now, you've taken pictures, turned it into PDF, saved it on your desktop perhaps, you've went to Canvas, you've went here, you've uploaded it, you're really happy, you're off to have a coffee, and you look round and you figure out, darn it, there's 2 more pages that I meant to send. I just realised that I didn't take pictures of them. What did I do? What you do is you hit resubmit assignment. Well, right back. What you do first is you take some more pictures of your working. It's a good idea to do the thing from scratch, because if you only take the last 2 pages and you upload it, it will rub out your old answer and it will replace it by 2 pages instead of 8. So what you need to do is you need to do the whole thing again, right? All 10 pages now. Save them, all that stuff. Come here, load it up. Come on. Oh, sorry. Choose a file, load it up, hit that fella, submit. Right, so you can submit it. I don't know, maybe you forget a couple of pages. You know, sometimes you say, oh, I could put in some work in here that I maybe not did the first time, but I know, I skipped it because I was in a hurry and I wanted to do in my head. You can alter it a little bit as well. Are there any questions about how you are going to upload your working and the process that you're going to do that? You feel comfortable about it?
I have a quick question.
Yes.
I recently cracked my phone screen, so it's kind of hard to use, and I'm waiting on a replacement. If I can't
Right.
do the PDF thing, could I just take normal pictures, like the .img kind of picture?
Yes. Please.
Okay,
Yeah. Yes, a good question. Please do not do that as a general thing. I know that's easier, and you've got a great reason for why you need to do it. But the rest of you, please don't do that. I'm going to be grading 100 plus, over 110, I think, exams. The last thing I want to do is have to go and look at 8 individual IMGs just to check the working for one person. My wife will not like me because I will be really grumpy at the end of that. So to make my family life much better, and so that she won't divorce me, you will use this method. But I understand that there can be circumstances, like in your case, I totally understand. You got to do it what you got to do, right? Now, if you take, wait a minute, let's rewind that. If you're taking pictures, it doesn't matter if your screen's cracked.
Well, I just meant like I might not be able to go and download the app, but I know.
Oh, okay. Okay, if you can't, that,
the
right,
camera.
then rewind it. Yep, you're fine. I think,
But I might get a replacement before then, so it might not even matter. It just
That's
depends
cool.
on when they
Right.
send me a new phone.
One note.
Yeah.
One note on that too. There are web-based utilities out there. I forget them off. It's been a minute since I've had to use one. But utilities out there that can take a series of JPEGs or what have you in file format and compile them into a PDF on your desktop or laptop or what have you. So
Oh, great.
the answer is Google there. Your mileage may vary on how well they work. As I said, I haven't had occasion to use one of those in some time, but they are out there. They do exist. So just another food for thought, something else you could do to make your life a little easier with that.
I'll check that out.
By the way,
Thank
it's
you.
making my life easier. It's giving him some extra work, but I like that version. So if you can find that and it works, some of you, I know it's unlikely, but some of you might have a printer that can do scanning, which could do it that way. I don't care how it became a PDF. I just need it to come as a PDF. And that just makes my life easier because when I go into Canvas, I basically, I have on one of my screens your WebAssign test with all your, what you wrote down in your scores, because WebAssign will grade it, and then I have your working. I do a one-for-one check, and that's where your partial credit comes, because you might have written down virtually the right answer, but a plus where a negative should be, and WebAssign is going to say 0 out of 20 to me, which I know is not right. And then I look at your working, and it depends on how bad the error is, how many points I take off. So that's kind of how it's worked, and it's just so much easier for me if it's PDF and it's in Canvas. Otherwise, I have to hunt around for an email for that person and then look at 8 pages one at a time, and that's really, really time consuming. So that's kind of the end. So we've talked about what you do at the end. Let's talk about what you now do at the start. At
I have a question.
Oh, great. Questions are better. Go.
So whenever we use the WebAssign, I don't know, probably a couple quarters ago, if we did our tests or quizzes, it sometimes timed out.
Yeah.
And had us go back in, and they gave us a whole another set of questions. Did they fix that yet?
No, they haven't. Not that I know.
So would it be a different set of questions if we get kicked out again?
Yeah. So
Oh, hell.
don't
Okay.
get kicked out. So
Okay,
none
thank
of
you.
your kids can watch Netflix if you've got kids, right? If you stay
Yeah.
at home, nobody's watching anything, texting or whatever, because if you've got a dodgy internet, the more people using it, the more dodgy it becomes. So you're lucky, and I guess you're lucky because it's the morning, so maybe they'll not even be up yet. But no, they don't do that. A good question. Right, so your exam is going to start at 7, it's going to finish at 9. It's timed. You have 3 hours to do it. Everybody will get, you know how WebAssign gives you the question but changes the numbers, right? So that will be true. So when you go in again, just like she said, you go out, oh, I get knocked out, I go back in, I'm in trouble, right? That, you got to live with that. So the good news for that, and I just thought of this as we were speaking, let's suppose there's 12 questions and you got to question 9 and it kicks you out. Don't you have the working for the first 9 questions?
Yes.
So all you need to do is do questions 10, 11, and 12, right? Do the working for them. And you could theoretically, couldn't you just theoretically put 42 on all the boxes and just send me the working? Right? So you don't, I've just figured out, you don't actually, now that I've figured that out, you don't actually need to do all the questions that you get kicked out for because you've got the working for them, right? So they physically still exist. God, that was a cool thought. I'm glad you gave me that question, because I could imagine someone that happens to, and then they're panicking like mad, because I've only 20 minutes to go and I have to redo the midterm and, you know, all that stress. Cool.
One
I'm gonna-
question with
Yes.
respect to that, because I've never actually taken an exam in WebAssign, but
Yeah.
obviously having done some of the homework, each question in the homework has its own submit button that then appears to lock it in or submit it in some fashion.
Yeah.
Do exams work differently than that? Is there only
No.
one master submit for the whole thing?
Oh. I was about to say each question gets submitted.
From what
Um,
I remember, it was at the very end.
Okay, thank you for
So there's no
clarifying.
individual,
I could be
so
wrong.
Kim, there's no individual
Yeah.
submit button to your knowledge then, as opposed to the way the current homework works, right?
Yeah, I guess I should
From what
set
I
up a
remember.
test and do it. If I rewind back, the exam is online. It's using WebAssign. The questions are from WebAssign, so they should be exactly the way WebAssign asks things. You know, sometimes a textbook and homework do it one way, and then your professor goes and asks it the way they tend to ask questions. You know, and there's a little discontinuity between them. It's basically it's taking questions straight out of a test bank that they have. So the questions should be just like you've seen before. So there shouldn't be any "what the heck is that about" kind of reaction. And you go through them just the way you would. I've been told at least that there's a one mega submit. Well, I wouldn't hit that button if there's only one submit means the whole test. Keep away from that thing like the plague. Because you know, when you've done that, that's pretty much going to be the test over with, and I don't think you'll be able to get in to look at the questions. I think if you get a crash and a lockout and you go back in, that's fine. I know that's designed to let you back in, so that's not such a big problem. I believe if you don't do submit and time runs out, it's just going to auto submit anyway. So you know, it'll send, you know, the result anyway, so you should be fine. Does that kind of answer the question? Right. Looks just like normal. I still haven't made the test. I'm making it I'll be putting it together on the weekend. You'll get different versions based on the fact that there are some numbers that get changed. But that's not just what's likely to happen. What I tend to do, and that's why it takes a little bit longer, is I do pooled questions. And all that means is I get 3 similar questions, but not just with the numbers changed, which is an easy switch, but with one of them's got a sin t and the other one's got an e to the t, and something that's got they're the same quality of difficulty, but they're different, if you can guess what I'm saying. And so what will happen is that you will find that you may, when you go and back and say to someone, I was doing question 4, and that sin t cubed was a real pain in the butt, and they're going saying, what sin t cubed? I never had that in this question. You know, those kind of discussions. That's why. So if you go back and you're wondering why your questions might have looked a little bit different from the others, that's just part of my process. They change all the numbers, so you'll get that. There'll be a Zoom meeting that'll start at 7, probably finish at 10. So if you have problems with, for instance, uploading your working, you can talk to me in Zoom. I mean, it'll be like this. You'll just basically have Zoom on and not talk to me. I'll mute you all so you don't bug each other. And don't show your answers on the camera, because I'll see you. Right? That's like looking over at the other guy's paper. That's a little bit too
So,
obvious.
Mr.
So
Robinson?
don't do that. Did you just call me Robinson?
Robertson.
Yeah,
Oh,
too
you
late.
did.
You just called me an English name. That is the
It's okay,
height
I
of
still love
insult.
you.
Say that again.
So I'm very new to this Zoom thing,
Uh-huh.
and I only have one screen. So can I still keep your Zoom up so you can see me while I am like submitting my answer? Is that how
Yeah.
it works?
Yeah.
Okay,
You
cool.
won't. Yeah, you can do it easily. I have a little button. You know, I'm out and in. Do you call it? What does it look like from your side? I've never zoomed from your side. What do you see?
I just see pretty much I enlarge it, so I only
Right.
see what you're seeing, so I don't have to focus on anything else.
Yeah,
Okay.
you can simply just minimize the screen and it keeps the
Okay.
meeting running.
Right. I will still see you. You just won't know that I can see you, I guess.
Okay, cool, thanks.
Right. So that's in as well. So yeah, in your case, I could do that as well. I just noticed I can minimize the screen, but I don't tend to do that because then what's the point? Your test is going to be chronological. So when you get your test, the first questions are from the first section that we did, right? Way back in the day. And obviously the last question that you're getting will probably be something like, here is R of t, find the velocity, acceleration, and speed, right? Something like that. That'll be the last one that you'll see. Any other questions?
Are the questions that you're pulling just pulled from WebAssign, basically?
They are, but they're pulled from WebAssign, but not from your homework questions. They're pulled from another pool that they've got, another group of questions that they have where, I can't remember the name, they probably call it Test Bank or something, right? And that's where I pull them from.
Yeah, I'm just wondering if it's like similar format to what we're
Oh, it
doing,
will
just-
be. It will be. It'll be, you know, you see that question I just said, R of t, find the other three? That's exactly how it's going to look.
All right,
right.
awesome.
You might, if you're lucky, get a helix. You might get something that has a perfect square in it, so you've got to work a little bit harder on it. You will not get, do you know how in your homework you get show me one like it and give me some help and whatever other phrases they use, that kind of thing? That will all be locked out. So all you will get is that question with nothing else to look at. You will also only get one shot. So whatever answer you lock into WebAssign, whatever you type in is it, right? Now, I think since you've got a final submit at the end, you should be able to go back and change that number if you did something, because it won't lock it in until you hit that submit button. And if it's a single submit, that's fine. If it ends up being individual submits, I honestly don't know. But if it does end up being that, then make sure that you're comfortable with your answer before you submit. The backup, of course, is since I can see you're working, even if you screw it up, won't I still see what the working was, and I'll know what the answer would have been that you typed in, even if for some reason you typed in the answer to question 7 in the box that was for question 8, you know, whatever weird things that you do. Someone suggested in another class, and this is a good idea, if you have dodgy internet, you might choose to print out the entire midterm. Right? You can do it whatever way, screen. There's ways to do it, right? Print the darn thing out, and then can't you just do everything on paper and send it to me? I would only suggest you do that if you know, as a backup plan to the internet dying on me and causing me a great deal of grief. But that's a suggestion. If you think your internet's a bit twitchy, you could maybe try it that. Okay, let's talk about the cheating rules of the game now. You are not allowed to talk to any human being about this. That includes living or dead. The second rule is you're not allowed to use Mathematica or any fancy software. So if you suddenly do velocity, acceleration, and speed, and you do it in Mathematica, all you will be writing down are the answers. And when I see you're working, I won't see any working. And if I don't see any working, I don't care if it's right. You're getting 0 points, because to me, you didn't do it. You plugged it into software, whatever it was, and you did it. So if I don't see the working, you ain't getting the points. That's the rule of the game. So don't use Mathematica, because all Mathematica will do is tell you the answer probably, and don't go anywhere clever where you might be able to do more than that, because that's cheating, right? So
we can't use a Ouija board to summon Isaac Newton.
yes,
or
exactly.
something?
If you and don't. I've been told that Isaac Newton is a very bad choice because pretty much drunk all the time now. He's not very coherent. A much better person to ask is Leibniz. He's much easier to get through to, but you have to speak German fluently, so you have to brush up on your German. Descartes' pretty cool, but he's strange. But
It's a good idea.
yeah, not Isaac Newton. I think too many apples may have fallen on his head as well. Oh,